Taking a look at 6 here. The integral from 2 to 4 of dx over 5 minus 3x. So we want the area under the curve. We want to integrate. I think we're going to need a u substitution on this one. And so let's take a look. If u is 5 minus 3x, then du is the negative 3. And I don't have a negative 3, so I'm going to need to do my negative 1/3 in front. And then I like to practice changing my limits. I'll put it right here. I'm going to put the 2 in. If x is 2, 5 minus 6 is negative 1. If x is 4, 5 minus 12 is negative 7. We just don't have to do the substitution later if we do it right away. So negative 1/3, the integral from negative 1 to negative 7 of 1 over u du. Then we take a look. The integral of 1 over u du is the natural log of u. Keep that negative 1/3 from negative 1 to negative 7. And this is where that absolute value comes in. So negative 1/3 natural log of 7 minus natural log of 1 with our absolute values. The natural log of 1 is 0. So I've got negative 1/3 natural log 7. Where's that at? There it is, b. All right, let f be the function x cubed minus 6x squared plus 8x minus 2. What is the instantaneous rate of change? What is the I-ROC at 3? Perfect. So we need our derivative at 3. F prime is 3x squared minus 12x plus 8. F prime of 3 is going to be 3 times 3 squared minus 12 times 3 plus 8. And we get, let's see here, 27 minus 36 plus 8, negative 1. All right, someone is walking along a straight line. Let's draw the person walking. And let's talk about them walking. First, they're going away until K. Then at K, they turn around and actually go past. And I say they go past because this area is bigger than this area, so they're actually going to end up further this way than they were. Got to understand that when we're talking about a particle moving in a straight line. It's just someone walking north and south. The graph is shown from 0 to m, where j, k, and m are constants. The graph intersects the horizontal axis at 0 and at k, and at t equals m, and as horizontal tangents at j and l. For what values of t is the speed of the particle decreasing? They threw it in there. They threw speed in there. So it's easy to see that the velocity is going down from here to here. From j to k for sure. So you've got to find something with a j to k. And then I think you should continue talking about this. From k to l, it actually accelerates from k to l, and it has like a maximum speed here because of the absolute value. Then it slows down again from l to m until back to 0. Talking about going back to 0 would be important, I think, for the deep understanding of this problem. So clearly it's got to be C. Number 9. We've got a function for which of the following values is f not continuous. So we look at denominators. 2 and negative 1, something is happening. And the thing is, even if like there's going to actually just be a hole at 2, but it's still not continuous. So really that's our only option. We could go a little further in the discussion of we've got a cubic on the top and a quadratic on the bottom, so our horizontal asymptote, I'd like to keep having that conversation, is going to be infinity as well, or does not exist because the degree is higher in the numerator. All right, a particle moves along the x-axis. Here's our person walking with a velocity of 3t squared minus 4 after 0. If the person is at -2 at time 0, what is the position at 3? So to find the position, we just need to integrate -2 plus the integral from 0 to 3 of 3t squared minus 4. No calculator. So t cubed minus 4t from 0 to 3, -2 plus, let's see, 27 minus 12, plus 0 is the next part of it. So 15, so 13. There it is. Good job.